Hallo, it's dumplet here. Here's an item on geometric probability. So randomly choose 3 vertices of a regular octagon. Find the probability that the 3 points chosen form a right triangle. So this question came from DAM 2022, an exam that dumplet has hosted. The link to the PDF file will be in the description. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. So here we're asked about a probability. So it's going to be one of those favorable cases divided by the total number of cases. So we have to count first how many possible ways can we choose 3 vertices such that it's going to form a right triangle. Now before that, I'll just draw a circle around it, because a regular octagon or any regular polygon is always cyclic, so we can just kind of think of those 8 points as equally spaced points on a circle. Here we have 8 points. So let me just choose 3 vertices that work based from the figure. So I know that if I choose these 3 and if I'm going to connect them here, I'm pretty sure that it's going to form a right angle here. So this would be a right angle. Let me highlight it in green. Okay, red might be better. There you go. So this angle must be right. And well, from this observation, we can kind of say that this part, it's going to be the diameter of the circle. Well, because by the Taylor's theorem or by the inscribed angle theorem, this right angle, it's going to intercept a semicircle here. So that's going to be the logic here. So I think if we want to have a right triangle, so we just clear things here. So if we want to have a right angle or a right triangle, to be specific, we have to choose 2 points that are directly opposite. So that are opposite to each other. So that are opposites. Right, so we have to choose 2 points that are opposites. Now we can easily list down the possible options here. So apparently what we have to do here is, okay, just make sure that the 2 points are opposite. And I believe the third point, it's actually not going to matter. So for example, I'm going to fix these 2 points. So this one is going to be the first fixed point. This is going to be the second fixed point. So those 2 points are opposite, diametrically opposite. So those 2 are antipodes. And then I think the third point doesn't really matter. I just have to choose a random point. Let's just say I'm going to highlight this in green. Let's say this point over here. And I believe if I connect these 3 points, I will still form a right triangle, because by the Taylor's theorem again, this angle would intercept a semicircle and it's going to be right. So that's going to be the goal first. We have to choose 2 points that are opposites. That's going to be our first step. And then I believe the next step, choose a third random point. Choose the third random point. So it's really just a matter of counting how many ways can we do the first one, which is to choose 2 points that are opposites, and then choose the third point. So let's try to think, how do we do this one? So let's talk about the first step. We'll have to choose 2 points that are opposites. So I think here we can just count, because we could talk about this one. I'm gonna label these as A, B, C, and D, so pairs. So let's just say the first pair, let's say this is the first one of the first pair. Let me just call this point A1, then this point would be A2. So that's going to be the first pair of diametrically opposite points. And then it's going to be B1 here, B2 here, C1 here, and C2 here, D1 here, and D2 here. So in total, I could have 4 pairs. So I have 4 pairs. I'm going to write the 4 here. So 4 pairs of diametrically opposite points. And I'm pretty sure for each of these 4 pairs, I can have how many triangles? Well, for each of these 4 pairs, we're going to have 6 set of right triangles. Now, why 6? So I have to multiply 4 and 6. Now, why 6? It's because, let's just say, for example, we've chosen the pair A1, A2. Since we want to have a third point, as we can see here, so after we choose the 2 points that are opposite, we are going to choose our third point. So the third point, it doesn't really matter. Just make sure it's distinct from the 2 points we've chosen. So in this demonstration, I've chosen A1 and A2, and we have 6 remaining points. So the B1, C1, D1, B2, C2, D2, these are the remaining points, and that's why I have 6. So there are 4 ways to choose the pair, and then for each pair, there are 6 ways to choose the third point. So there is going to be a total of 24 favorable cases. So there are 24 possible right triangles that we could form, and we just have to divide it by how many ways are there in total. That's going to be 8 vertices, choosing 3 of them. So we just use the formula for combination, 8 factorial divided by 3 factorial, 5 factorial. You can write this as 8 times 7 times 6 divided by 3 times 2 times 1. We could cancel the 6 out, and that's going to give us 56. So we have 24. So this is equal to 24 over 56. Both the numerator and the denominator has a factor of 8. So in simplest forms, the probability that the chosen vertices will form a right triangle is going to be equal to 3/7. So 24 over 56, that's equal to 3/7. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye.